Hello, grade 11s. I wanted to show you an alternate method to finding the vertex from standard form. Let's have a look. Traditionally speaking, when it comes to converting standard form into vertex form, we do something called completing the square. It works quite fine. I wanted to show you a different method. Okay, before I show you the method, I want to show you why it works. So, starting from the quadratic formula, we have this. Now, you may have noticed in the quadratic formula, we have to do this plus or minus business because of the square root. When we square root an equation, we have to consider both the positive and the negative root. As an example, 5 times 5 is 25, but so is negative 5 times negative 5. Because our calculators will only give us one value, because when we take square roots, normally we take the positive value. For equations, we have to consider both the positive and the negatives. And that's important here because essentially we want to translate what we think of as positive and negatives into a right solution and a left solution. Okay, if we split up the fraction into two parts, the negative b and the root part, well, they're both over the same denominator 2a, and they're being added or subtracted, we can split up into two fractions. In the addition fraction, it will look something like that, and in the subtraction fraction, it looks something like this. You will notice that there is a negative b over 2a part in each of these solutions, what I call the right solution and the left solution. The right solution because we are starting at this certain value, negative b over 2a, and then we move to the right by a certain amount to land at our first x-intercept. For the second one, we are starting at the same negative b over 2a, but this time we're subtracting the root part to go to the left x-intercept. So what could this special value be that where we move equally to the left or the right, we land at x-intercepts? It turns out this special value, negative b over 2a, is our axis of symmetry. Our axis of symmetry, I'll call it xAOS, is equal to negative b over 2a. And all we're doing is we're doing midpoint formula with the quadratic formula. Let's have a look. So what does that mean graphically? That means is if I drew a axis of symmetry to cut down through the vertex of this quadratic over here, we moved to the right by this root part to land at our first x-intercept. And then we also, we started at that same line, that axis of symmetry, and also moved to the left by the same amount, but obviously just subtracting to go leftwards to get the other x-intercept. So something very special about this negative b over 2a. We're going to leverage this in how we find vertex form. Okay, into the actual method itself. We're starting off with that point where we said that the axis of symmetry for any quadratic in standard form is negative b over 2a. And that helps us a lot because that also tells us our h value. Our h value is equal to negative b over 2a. If we can find that, we can very easily solve for the y value, the k. So here, in our example, we're still sticking with the same one here. We have an a value equals to a 2, a b value equals to a negative 5, and you may notice c does not help determine the location of our axis of symmetry. Okay, let's plug in everything. Let's find out where this axis of symmetry exists. For this one over here, we have AOS is equal to a negative 5 divided by 2a. We know a, it's 2 times 2. This is negative 5 over 4, negative 5, my correction, my mistake there, which is a positive 1.25, and looking promising already. But imagine that we didn't have this picture for us already. Now, how would we go about solving for the y? We simply have to plug it back into the original formula. So we're going to plug it back into, let's do something easier. We're going to plug it back into here. We're going to plug it into the original formula to solve for the y value. So we're going to sub in. And be careful with BEDMAS here. The rest is just good calculator work. And I'm going to skip a little bit of work here. I'm going to cheat. I'm just going to copy this negative 7.125. At home, you can confirm for yourself that that is the location of the vertex. Now, the beauty of this is we can also go use this not only to find the vertex, but also vertex form. This method of using the axis of symmetry will get us this far. We have solved for our k value, we have solved for our h value. Vertex form looks like the following. A, x minus h squared plus k. In this example here, well, we have an x minus 1.25 squared plus, well, it's a negative, minus 7.125. The only thing that this method is missing is a direct way to calculate a. Well, conveniently, a is consistent along all three forms in quadratics. We can just steal the a value from the very beginning. And here we have our equation in vertex form.